Now we're going to do an example of a step function, and a step function is also can be called, we're going to do the greatest integer function, so we're going to do that now. All right, as we've talked about the greatest integer function, you put any kind of decimal or whole number in there, it's going to be the greatest integer not exceeding that number. So first, to graph this, we're going to start off with just integers. So what we're going to do is we're going to start off with 1, we're going to go 2, we're going to go 3, and then we're going to do 0, -1, -2, -3, just to get us started. And you're going to see something very familiar. Now, so we're going to put this in here, and we have 1. The greatest integer of 1 is 1, and that turns out to be a -1. Okay? The greatest integer of 2 is, of course, 2. You've got the negative sign in front, so that's -2. This right here is going to be -3 with the same reasoning. You're going to get a 0 for this. Okay, now when we put a -1 in there, so you're going to have the greatest integer of -1 is going to be -1. You take the negative it's +1. This is going to be +2 with the same kind of thinking, and this is going to be +3. So what we're going to do first is we're going to graph these dots. So we have 1, we have -1, we have 2, we have -2, we have 3, we have -3, 0. Then we have -1 is 1, -2 is 2, and -3 is 3. So this is not very unusual at all. But now we're going to start putting decimal values in. And we're going to start with 0.5. So we put 0.5 in there. And we want the greatest integer for 0.5 that doesn't exceed 0.5 is 0. All right, so this turns out to be 0 because the negative of 0 is 0. So we have 0.5 is 0. So now we're going to put in 0.1. And you're going to see the exact same thing happens as that. And you're going to get 0 again. Now we're going to do 1.5. If you take the greatest integer of 1.5, that is going to be 1. And you're going to wind up with -1 because of the negative in there. So then we're going to do -0.5. This is where it gets a little interesting here. So if we have the greatest integer of -0.5, that means the integer that's closest to it but does not exceed it, you're going to wind up with a -1. So now we have negative of -1, which is going to be equal to 1. Then we're going to try -1.5, and you've got the negative. When you want the greatest integer of -1.5, that is going to be the integer that is closest to it but doesn't exceed it. So that's going to be -2. So now you have negative of -2, which is equal to a 2. All right, so we're going to graph this and see what it looks like. We take 0.5, that's right here. That is also 0. All right, so that is actually right here. So you've got 2 points right here. And then if we have 0.1, that's also a 0 right here. So how we represent this is all of this in here, from just a little bit over 0 to just a little bit less than 1, we put up there, put an open circle, because once it's 1, it's -1. Okay, so now let's do the 1.5. If we have 1.5, we wind up with a -1. And look, that's on the same line that you had with 1. So if you have several of these, it's going to turn out to be like that. So now let's look at -0.5. -0.5 starts here, but that turns out to be a 1 up on the same line as this. And again, the same, if you try other decimals, you're going to wind up with that. And then if we try -1.5, that's right here, that turns out to be a 2 up on the same line as this. This works the same way, so I am just going to do partial here. I'm going to do from -3 all the way up to just a little bit before 4. And there you see what's called your floor function because it goes here in your values. Okay, and when you put decimals in, the decimals wind up to have the same y values. It still is a function because each x has its own y. Not one x doesn't map to two y's. One x, each individual x maps to a different y. So there you have, it's called the step function. See, it looks like stairs going down.